Welcome everyone. This is part 3 of our blocks diagram discussion. What we're going to be doing today is looking at this expanded block diagram of the system we were using in part 1 and part 2. I'll discuss a little bit about it. And then our next video we'll actually do some inspection of an interface definitions for some of the signals in this block diagram. So here's our block diagram in question. You'll notice there's been a lot of movement and expansion and kind of rework of this from part 2. But you will notice on the left-hand side over here, we're still seeing our outside to solar panel, our outside to enclosure, and our outside to sensing inputs, as well as our global output web display outside user out. You'll notice I did go through and I shortened the names. I took out the 2 just to make them a little more readable. The actual web tool that you guys will use does not include the word 2. It just shortens it down. It also actually removes all of the vowels from all the words just to try to get this as tight as possible. When you are doing your graphical block diagrams, make sure that the names you use in your graphical block diagram match the names that are auto-generated by the web tool. This is really important because otherwise I can't verify, or I or any of the graders can't really verify which interface is which, at least not with certainty. So let's look at this in general. So you'll notice that I've kind of created 2 flows to the design. There's the power flow running across the top here, and then there's the data flow running across the bottom and kind of turning up the side. Many of the projects you'll run into or that you'll work on in your career will probably have this type of a form, where they'll have a flow of data or a flow of power moving throughout. There are some situations when there's multiple data streams coming together to a central point, and then those are moving in and out to other points. But in general, this flow diagram this flow shape is pretty common. You'll notice that the enclosure only has a connection coming from the outside to it, but it actually has no connections going out. Technically, the enclosure is probably connected to almost everything in this design. But because of that, we're not actually explicitly calling out those interfaces to each and every possible thing. Now that being said, if one of the interfaces was special in some way, for example, maybe your enclosure is also part of your heatsink for your big power supply, maybe not in this system but in another one, you'd want to expressly call out the interface between enclosure and power supply to make sure that special attention was paid to the design of that interface. You'll also notice that when it comes to the power supply, the outputs are kind of left floating, but they're picked up again by floating inputs on the corresponding blocks. This is a useful technique to make sure that your diagram doesn't get too complicated with wires and interfaces running every which way. That being said, please make sure that, especially for the primary flow type interfaces, that those are drawn into place. Otherwise, it's very hard to understand how your system works. So I would recommend only using this for power and power supplies. Okay. Let's give you a little bit about how this works just so you get an overview, because we'll be doing interfaces in our next video. So we have the outside sensing environment, depth and temperature sensing. This is converted to an analog signal. This implies that probably within this processing block there's going to be some analog to digital converter. Well, actually it almost necessitates it. And this might change as we move forward with the design. Also coming into the processing block is the code. So this interface is of type code. You'll notice the last 4 letters there is code. And that type of interface should specify how the code is downloaded to the hardware, how the code interfaces, and maybe some of the data elements or the configuration settings possibly that are needed. It's a little flexible based upon what type of a processing system you're actually going to choose to use. Also, the processing is powered from the power supply processing DC power input. Now notice this DC power input, DC power, doesn't have a voltage encoded in the name. This is important because once you've specified a voltage within the name, you can create some very confusing things. Many times I've seen students show me an interface where it says 5 volts in the interface name, and by the end of the course they're using 3.3 volts or 2.7 volts for power, but they've left the name as 5 volts. I've run into a few groups that just because of the name, one of their users managed to fry their system because they read the interface name, not the fact that it had been changed to 3.3 volts in the interface definition. So try to avoid those in the names themselves. The processing element then puts some data together. Oh, looks like I missed a name right here, processing to network data. So let's go ahead and make a copy of that. Put that back where that belongs. Try that again. All right, there we go. So then the processing system takes that data, takes that information, and puts it into a format that the network hardware can handle and transmits it. Notice it's of type data. So data types imply that there's a certain quantity of information sent per second. There's probably a format to that type of data. There might be some example commands or some example special operations that exist within the data that could be listed out. A variety of options there. As you're putting this information into the block diagram tool on the web page, you'll see there's a lot of options for types. And then within that, there are some suggestions for what these types could do as well. A network block then takes in some power. It takes in that data from the processing block, and then it transmits it network to server. This isn't really defined, but most likely this is going to be a wireless connection. I could have chosen to make this network to server wireless. If I had done that, I would be describing the wireless protocol, I'd be describing the frequency at which things were operating, the network topology, things of that nature, the CDMA versus GRMS versus et cetera, et cetera. But those things are kind of built into the hardware I'm planning to buy, and they're going to be very hard to prove that they're doing. So instead, I chose to take this as a data approach and talk about the information that's being sent over this network from this network hardware to the server code. Then the server code takes that data and puts it on the web page. Again, from previous videos, I chose to break the web display and server code into two different parts. The reason being that the server is just going to accumulate data at some rate based upon however often it gets a sample or gets data from the rest of the system, whereas the web display is going to update at a different rate and also might display different information. The server might even do some calculations. It might do some averaging or some trend projections or things of that nature based upon the data that it's getting. And so then the web display actually displays slightly different information than the raw data coming into the server. And then finally, that data is displayed to the user in some format, whether it be a graph or it be a stop sign or a traffic light of some sort. That's kind of up to me and the user, and I could define that within the scope of the interface definition for that web display to outside user out. So that kind of gives you a little bit of a flow. In the next video, we'll spend a few minutes looking at a couple of these interfaces and some of the interface definitions that are associated with them to try to help you kind of get the best possible design. Thank you.